So exponential decay and growth, including graphs, tables, and transformations. Let's first start off with a review of exponential equations.
So first we're going to compare exponential versus linear equations. So exponential equations follow the form y equals ab to the x, and their rate of change is not constant, so it increases or decreases by a different amount each time. And an example would be y equals 5 times 2 to the x, versus linear equations, which follow the form y equals mx plus b. Their rate of change is constant, and an example would be y equals 3x plus 1. In exponential equations, there's also exponential growth and exponential decay. So for exponential growth, that's when the quantity increases exponentially. And then, so the a would be greater than 0 and the b would be greater than 1. So an example is y equals 2 to the x. And for exponential decay is when the quantity decreases exponentially. So a is greater than 0 and b is between 0 and 1, so y equals 0.5 to the x.
Now we're going to look over graphs, tables, and transformations. Let's start off with graphs and tables. So on the left, we have a graph of an exponential growth equation. You can see as the x value increases, the y value grows drastically. So now let's look at a few points. We have when x is 0, we have y equals 2, because 2 to the power of 0 equals 1, and that times 2 will be equal to 2. Now we see by when the x value increases by 1, we multiply the y value by 2. Now let's look at exponential decay. We see as the x value increases, the y value decreases, but the farther we go right, the less it decreases. So an application of this is half-life. But first, let's look at some points as well as the trends. If we look at what when the x value is 0, we have the y value is 3, because 0.5 to the power of 0 is 1, and that multiplied by 3, it will be equal to 3. Now when the x value increases by 1, we multiply the y value by 0.5. You see it just decreases by 0.5 each time. Now let's match the equations to the graphs. You can see we have y to the power. Okay, I'll actually just stop, and you can pause the video and try and match them yourself. Okay, so for the first graph, we have y equals 6 to the power of x. For second graph, we have exponential decay, which is y equals 5 times 0.5 to the power of x. For the third graph, it's 4 times 3 to the power of x. And for the fourth graph, it's 3 times 2 to the power of x. Like here are the answers.
Okay, so now we're going to be looking at transformations. So the first one is a vertical transformation, and for these we consider the k variable, and the equation is y equals a times b to the power of x plus k. And with k you can either move up or down on the graph, and an example would be y equals 5 times 2 to the power of x plus 3, which means the graph is shifted up 3 units from the original one. And then y equals 2 times 3 to the power of x minus 5, which means the graph is shifted down 5 units. And then these are just the two graphs. So for the first one, the graph is shifted up 3 units from the y coordinate of 5. And then on the second graph, it's shifted down 5 units from the y coordinate of 2. And then now we're going to look at horizontal transformations. So for these we consider h, and the equation is y equals a times b to the power of x minus h. And with horizontal shifts you can either move left or right of the starting function. And an example would be y equals 5 times 2 to the power of x minus 3. And so the graph is shifted 3 units to the right. And then y equals 2 times 3 to the power of x plus 5, which means the graph is shifted 5 units to the left. And then these two are just the equations again, and so the first one, it's shifted 3 units to the right of the starting function, and then the right graph, it's shifted 5 units to the left.
Let's go ahead and practice these different transformations that we just discussed about. Here you're given 4 different equations, so go ahead and pause the video now in order to state which of the transformations will be applied to the equations. Okay, let's go ahead and see the answers. All right, so for the first equation, your equation will be moving 7 units to the right. So that means if you have x equals 7, then it will be the same if it was x equals 0 if there was no transformation not being applied. For the second equation, you have the equation being shifted 4 units up, so that means your graph will be up 4 units on the graph. For your third equation, it will be down, moving down on the graph by 3 units. And finally, your fourth equation, your equation will be transferred over to the left 5 units. And that's it. Hopefully, got all those answers right.